So, let's talk about circles. What's special about a circle? It's different than other shapes. Yes? It has a center. The center of the circle is special. Why is it more special than like finding the middle of a square? It's equidistant from all the points on the circle, okay? That's a good thing. What else do you know about circles that's, they have their own special language. I mean, squares don't have their own special language. Circles do. What am I talking about? Pi is involved with circles. What else? Yes? Radius. Yes? Circumference. One more that we haven't talked about yet. Yes, diameter. Okay, so this circle here has got all kinds of ways we can describe it with radius and diameter and all that stuff. But let's just talk about in our society. I mean, have you ever seen like any references to circles in society? Yes. Okay. And that was just a reference, a student talking about a parent using them at work. Cylinders are based on circles. Yes? Pie charts are used a lot in real life. Yep. How about the circle of life? Have you heard of the circle of life? And that sort of implies that it sort of keeps going, like that if you put an arrow on one side, that it's sort of, if you imagine it as something that can be in motion, that it just keeps going around. Infinity symbol is supposed to give you that same feeling that it doesn't end, it just keeps going and going and going. Circles are kind of an unusual shape, and we're going to be making equations for them. And so here are a bunch of circles. And by the end of this lesson today, your goal is to be able to write an equation for any of those circles. It should be like no problem. And it really is, it's pretty easy once you get the hang of it. All right, we're going to start with the original circle. This is called the unit circle. And unit just basically means like most basic, or 1. The unit circle has a radius of 1, as you can see. I kind of zoomed in here to make it really easy to see, even the small numbers. And I'm going to show you how we can derive the area, or not the area, sorry, the formula for a circle, the little equation we can write, by using x and y. Would you agree that a distance that I draw down here is x? Isn't that an x distance? Okay. And then would you agree that the distance, if I go up, straight up, like a right angle here, that would be a y distance? All right. Then you'd have to agree that this distance right here, the green distance, would be what? No, don't try to do too much here. That's the distance there for that green one. That green one is how long? Come on, use your head. It's 1. It's 1. It's just 1. The distance from here to here, that is 1. All right, because if it was 1 down here, then it's got to be 1 over here. It's the same distance, right? It's a radius. Okay, so let me get back to just my one green line there. Now, let's see if you can figure this out. That's x. That's y. And that's 1. Some smarty pants can write me the equation for a circle from that. See if you're that smarty pants. Oh, somebody's onto something. Want to give it a shot? You have got it. X squared plus y squared equals 1. You pulled out the old Pythagorean theorem. That x squared plus y squared would have to equal 1 squared, but then 1 squared is actually equal to 1. And so it works. That is the parent function, the parent equation that we're going to go refer back to over and over again. Now, what if you thought he was wrong, but he thought he was right? How could you prove it? Hamish. Okay, so how do we figure out if it will, let's prove that this really works. Give me some numbers. 0, 1. Why are you picking 0, 1? 0, 1 is right there. It's on the circle, right? So it should work, right? So let's put in 0, 1. Everybody right now plug in 0, 1 into that equation. It's probably easy enough you can just do it in your head, right? I stick in a 0 and a 1. Do you see that it would work? All right. What else should work? Raise your hand if you can tell me another point that ought to work. Chess? 1, 0. Because that's right here, and that ought to work. And if I stick in a 1, 0 in here, put in a 1 and then a 0, it's going to work. 1 squared plus 0 is equal to 1. All right. I think you get the idea. And the last 2 points that are going to have to work. Jenna. Negative 1, 0. Yep. And 0, negative 1. And all of those will work too, because when I put a negative 1 in and I square it, it equals 1. So it worked. So bottom line is that we now have the main equation we're going to keep referring back to, this guy. And we're going to have to see what happens when we move that circle someplace else. All right, I'm going to switch to a different screen here. This is still my unit circle in red, and I'm just going to move him. If I decide to move him over exactly, let's go with 2 spots over. Now, think about this. It started out with x squared plus y squared is equal to 1, and now I moved it. Which way did I move it? To the right. I only messed with right, left, and so what does that mess with? The x. I'm playing around with my x, so I have to change my x. And instead of x, let's take a guess. I moved it 2 to the right. What do you think? Minus 2. You get that? All right. So what if I move it 2 to the right and up 1? Now I changed my x and I changed my y. Instead of x, I put something in parentheses, and instead of y, I put something in parentheses, and that still equals 1. Would you try to answer that, please, on your scratch paper? For my red circle, I moved it to the right and I moved it up. And it'll be interesting because a lot of you are going to get this wrong. Ashlyn, what do you say I should put by the x? Minus 2. What about the y? Plus 1. All right. How many of you said that? Raise your hand if you did. All right. Thanks for being honest, but that's not right. How many of you did something different? Drew. You are so right. You got to change that to minus 1. Because it's inside of parentheses. Remember how that makes it opposite? Counterintuitive? And so this thing moved up. And so we're used to the y's being something we can trust. Why can't we trust the y anymore? Because it's inside the parentheses. The stuff on the inside we can't trust. Same rules as before. Okay. Now, any guesses what's going to happen if I had the same equation but I changed this to like a 16 or something instead of a 1? What do you guess is going to happen, Kyle? Circle will get bigger. How big do you think it'll get? And that's a really common answer, but it's not right. Care to revise your answer? Radius is not going to be 16. Come on. Nope. You're getting closer, though. What do you think? Radius would be 4. Why 4? Yes. Square root of 16. And notice 1 was a weird one because 1 has its square root as the same thing as itself, right? And so 1, you can't really tell by looking at the 1 that it's actually the square root of itself. Okay, so what this all means is that if I give you an equation